I'm Lauren Cosby from The Ohio State University, Department of Biomedical Engineering and Public Health. Okay, and my research is on the drug delivery of for oral cancer chemo prevention, and my work is on encapsulating the lipophilic fraction of black raspberries for oral cancer. And oral cancer is the sixth most prevalent cancer worldwide, and new cases are steadily increasing each year, and it has poor survivability rates compared to the other top 5 cancers of the world. Current treatments include surgery, chemotherapy, and radiation, but all of those result in poor survivability, decrease in quality of life for the patient, and are very expensive. So our lab decided to take a prevention approach to addressing oral cancer. And there's extensive research that's found that black raspberries have anti-cancer properties, some of which include anti-proliferation and anti-inflammation. And inflammation is thought to be the main driver of oral cancer progression. And so a lot of work has been done with the anthocyanin-rich or hydrophilic fraction, and not as much on the lipophilic fraction. And that's largely due to poor cellular uptake and bioavailability. So my work is to develop drug delivery systems to encapsulate that fraction, the lipophilic fraction, and then evaluate anti-cancer properties for oral cancer. And so initially, starting out, we evaluated the extract's effect on cell proliferation and cell growth, and we found that there wasn't really any significant effect as we increased the dose of BRBH, which is the lipophilic-rich fraction. But a collaborator, so we thought that that was largely due to the low presence of lutein in the extract. We did a phytochemical analysis and found that to be correct. And so a collaborator donated a pure lutein emulsion for us to evaluate the effects of lutein on oral cancer. And surprisingly, we found that at a 10 micromole dose, the lutein emulsion did have an effect on decreasing cell growth of the premalignant cell line, or actually all 3 here. So we moved to encapsulate the lutein with PSPEO micelles and PCL-PEG micelles, which you'll see here. There are TEM images to show that we have created micelles and encapsulated the lutein, and then corresponding size distribution graphs for each of the micelle systems, PSPEO and PCL-PEG here. And we also evaluated encapsulation efficiency, which we found was low compared to other systems that we've evaluated. So we're looking into what may be the causes of that, and some of that may be due to chemical degradation throughout the particle synthesizing process. But we moved to evaluate cell viability and cell cycle analysis with using flow cytometry. We found the dose range to evaluate the cell cycle effects for lutein in SEC83 cells, and then saw that in the cell cycle analysis that there wasn't really any significant difference between any effect on any of the cell cycle stages. But we did see that as we increased the amount of lutein in the cells, that there was an increase in granularity of the premalignant cells. And that is thought to be so in literature, if there's an increase in granularity, that may be correlated to autophagy in the cells. So now we're going to look into some causative effect of lutein, the presence of lutein, and how that might be giving an autophagic response to oral cancer cells.
Thank you so much.
Yes, no problem.